8.5 is on applications of systems. That means how are systems used in the real world? Now, a lot of the problems you're going to do in this section are word problems, and a lot of times we dread the word problems, but they actually are going to bring some context to why you're learning how to solve systems. So example 1 says a farmer raises 5 times as many cows as horses. If he has 168 animals, how many cows does he have? The first step to solving this is to write your system. If we knew how many horses he had, we could easily figure out how many cows he has, but we don't. We only know 2 facts: that he raises 5 times as many cows as horses, and if he has 168 total animals. So the 2 equations I would write are this: the number of cows plus the number of horses equals 168. And I can also say if there's 5 times as many cows as horses, that means the number of cows I have has to equal 5 times the number of horses I have. Now, we would replace these with variables instead of writing it with words. So what I would like to do is choose the letter that is in front. So I would change this to C plus H equals 168. And C equals 5 times H. Once you have your system written, you can solve it. And there's 3 ways you've learned how to solve it. You can graph the system, you can use substitution, or you can use linear combination. For this particular one, since I already have C equals, I'm going to use substitution, and I'm going to take the 5H and plug it in for the C in the other equation. So my top equation is going to become 5H instead of C plus H equals 168. Add like terms together and I get 6H equals 168. Divide by the 6 on both sides, and this is going to tell me how many horses I have. 168 divided by 6 means I have 28 horses. So my horses equal 28. Now, the problem says how many cows does he have? We just figured out the number of horses. So, how many cows does he have? There's 2 ways that you can get this. We know that there's 168 total animals, so you can subtract the number of horses, and that will give you the number of cows that he has. So 168 minus 28 is 140, and that's the number of cows that he has. So we would say 140 cows is how many this farmer has. Okay, and here's example 2. Example 2, another word problem, says a collection of quarters and nickels is worth $3.70. There are 22 coins in all. How many of each coin are there? And again, to solve this, we need to have a system. We know that total they are worth $3.70. How much is a quarter worth? 25 cents. A nickel, 5 cents. We also know that there's 22 coins in all. So if I take the number of quarters and I add that to the number of nickels, that should equal 22. I can also say that if I take the number of quarters and I multiply that times 25 cents and I add that to the number of nickels multiplied by 0.05 for 5 cents, that will equal 370. Okay, now the second equation, if that's difficult to understand, if you have 4 quarters, 4 times 0.25 is going to give you $1. And then you're going to add however many nickels you have. So the reason these need to be decimals is because we're dealing with dollars here. So it's not 25, but it's 0.25 because that's 25 cents. Now, I want to get rid of the words and use variables to solve a system. So let's say that Q plus N will equal 22. And that 0.25 times Q plus 0.05 times N is going to equal 370. Now I can solve the system. Now, there's 3 different ways. Remember, you can graph it, you can use substitution, or you can use linear combinations. I wouldn't graph it, okay? These numbers are, like with the decimals, it's just too complicated. I also don't have an isolated variable yet. So the easiest way for me to do this would be to use linear combinations. So I'm looking for a combination that's going to make either the Q cancel or the N cancel. I'm going to try to make the Q cancel first. So I'm going to multiply my first equation by negative 0.25. I multiply everything in that equation by negative 0.25. And my result is going to be negative 0.25Q minus 0.25N equals 22 times negative 0.25. 22 times negative 0.25 is negative 5.5. Then I'm going to write my second equation down below it so that I can combine them and add them together and make the Q's cancel. So giant addition problem, add them. My Q's cancel because I have minus 0.25 and then I have a positive 0.25. The N's, I'm going to have negative 0.25 plus 0.05. And that gives me negative 0.2 N equals negative 5.5 plus 3.7, negative 1.8. If the decimals are throwing you off, remember we're talking about money here. So this is a quarter minus a quarter. This is 25 cents minus 5 cents, and I get 20 cents. This is negative 550 plus 370, and I get negative 0.28. Okay, so remember we're talking about money here. I divide by negative 0.2. On the left, I get N, the number of nickels, equals negative 1.8 divided by negative 0.2, which gives me 9. That means there's 9 nickels total. If there's 22 coins in all, how many quarters do I have? 22 minus 9 will give me my number of quarters. 22 minus 9 is 13. So there are 13 quarters. Now, you should always be able to check your answer and see if it works out. If you have 9 nickels and 25 quarters, 13 quarters, does that give you 370 like the problem says it should? Check it. 9 times 0.05 is going to give you the total value of your nickels, 45 cents. 13 times the number 13 quarters times 0.25 gives you 325. If you add these up, do they equal 370? Yes, they do, so you know you did it right.